This section is about balancing redox reactions. Balancing these reactions are kind of weird because you have to balance not just the elements, you also have to balance the electrons, because electrons can't just disappear. If something loses 6 electrons, it has to go somewhere. The way that you balance redox reactions is you start with something called half reactions. Half reactions show the oxidation reaction and the reduction reaction. So we're going to start by looking at this example here. In this example, we have tin, and it is losing some electrons, so it's becoming oxidized. And we have iron, which is gaining some electrons, so it's being reduced. So I can take these two things and I can split them up into half reactions, an oxidation half reaction and a reduction half reaction. I'm going to start with the oxidation half reaction, where I have tin2 becoming tin4. Now this is not the only part of the oxidation half reaction, though. You also have to show the electrons that it lost. It went from tin2 to tin4. That means it's lost 2 electrons. So I show those 2 electrons that have become separated from the tin ion. If I look at the iron, I have iron 3, which is being reduced to form iron 2. And here I have 2 of the positive 3s and 2 of the positive 2. So I have a total of a positive 6 charge over here, a total of a positive 4 charge over here. So this has gained 2 electrons. So I put that over here, 2 electrons. Notice, this is really important, that the number of electrons that my reduction half reaction has gained is equal to the number of electrons my oxidation half reaction lost. And this is always true. The number of electrons that is lost in your oxidation has to be equal to the number of electrons gained in the reduction. Always, always. So let's practice writing 2 half reactions and figuring out which is which. We're going to start with the example of nickel 2 nitrate and iron. This is the same example we just did a minute ago in section 20.1. So let's write down that same equation. And I'm going to trace my oxidation states just like I did before. I got 0 and 0, got positive 2 and positive 2. And remember, the nitrate really doesn't matter because it's not doing anything. And I'm going to see which one's being oxidized and which one's being reduced. I have iron here losing some electrons, so it's being oxidized. And I have nickel here gaining some electrons, so it's being reduced. And I'm going to split these up into 2 half reactions. Now what I am not going to include in the half reactions is nitrate. Nitrate is a spectator ion. Nitrate does nothing in the redox reaction. It never changes its oxidation state, so it is unimportant. So I am not going to include it. So here's the oxidation half reaction. Got iron turning into iron 2. It has lost 2 electrons, so I need to show those 2 electrons that it lost. Now I'm going to go to the reduction. And here is our reduction reaction with the 2 electrons that it gained. And notice that these are the same. Alright, so now we're going to get into the fun stuff. We are going to figure out how to balance these equations using half reactions. First thing you're going to do is figure out what's undergoing oxidation and reduction by assigning oxidation states. But one thing you're going to figure out is you really don't have to do that. You can usually skip on to step number 2, dividing your equation into an oxidation half reaction and a reduction half reaction, because you can figure out how these are going to work. I'll show you that. And then you're going to balance. First, you're going to start by balancing elements other than H and O. Then, you're going to balance the O by adding water. Then, you're going to balance the H by adding hydrogen, unless it's basic, in which case you're going to get really weird and add hydroxide. And then, you're going to balance your charge by adding electrons. Once you've balanced your charge by adding electrons, you have to make sure the electrons are the same in both of the reactions. So, if you have to multiply both of your or one or both or whatever your half reactions to make sure that they balance. Then you're going to add your 2 reactions together. You're going to cancel out anything that will cancel out. And once you're done, you're going to check and make sure your number of atoms balance and your total charge balances. And if it does, then you're in good shape. So let's go through an example of this horrible nonsense together. So we're going to take this equation right here, and we're going to balance this using half reactions. Now I can go through and I can figure oxidation states, but I don't really have to. Alright, if I'm dealing with any substances other than oxygen and hydrogen, like here I've got magnesium and manganese and manganese, they're part of the same half reaction. And here I've got carbon and carbon. They're part of the same half reaction too. So I can split these up into half reactions just by using common sense. I don't have to go through and figure out all these oxidation states. So here's my first half reaction. And here's my second. So I've just finished my second step. I've divided this up into 2 half reactions. If I go through and actually figure out the oxidation states, I find that my top reaction is a reduction reaction and my bottom reaction is oxidation reaction. That's really not that important, but I can figure it out if I need to. So now that I have my half reactions, I'm going to start balancing. First, I'm going to balance all elements other than oxygen or hydrogen. For the first reaction, my manganeses are already balanced. My carbons are not, though. I got 2 over here, I got 1 over here, so I'm going to fix that. Now my next step is to balance my oxygens using water. In my reduction reaction, I've got 4 oxygens on this side. So I need 4 oxygens on this side, so I'm going to add 4 waters. For the bottom reaction, I've got 4 oxygens over here, I've got 4 oxygens over here. I'm in good shape with my oxygens. Now I'm going to balance my hydrogens by using hydrogen. Over here, I've got 8 hydrogens, so I need to add 8 hydrogen ions to this side. And in my oxidation reaction, there are no hydrogens, so I don't have to worry about that. My next step is to balance my charges by using my electrons. I've got 8 positive right here, 1 negative over here, so I've got a positive 7 on the left-hand side. I've got a positive 2 on the right-hand side, so I need 5 extra electrons to balance this out. And so now I have a positive 2 on both sides of the equation. Now for my bottom equation, I've got a negative 2 here, I've got a neutral 0 going on over here, so I need 2 electrons on this side over here. Now notice that I have electrons being added to the reduction reaction. I have electrons being removed from the oxidation reaction. This should always be true, that electrons are being added to one and taken away from the other. They should never both be on the same side of the equation. Now my next step is to balance out the electrons so that they will cancel out. I've got 5 electrons on top, 2 electrons on the bottom. Best way to do this is multiply my top equation by 2 and my bottom equation by 5, giving everything 10. So I'm going to go ahead and do that. Now I'm going to take my 2 reactions and I'm going to add them together. And then my last step is to go through and cancel out anything that'll cancel out. I've got 10 electrons on both sides of the equation, so that can cancel out. And in this reaction, there's nothing else that'll cancel out. Usually you can cancel out some waters or some hydrogens or something else, but this is it for this one. So this is my balanced redox reaction using the method of half reactions. Let's go ahead and take a look at, There we go. Take a look at another one of these. Let's see if we can zip our way through it. So I'm going to start with my 2 half reactions. And now I'm going to balance everything besides hydrogens and oxygens. And now I'm going to balance my oxygens by adding water. And now I'm going to balance my hydrogens by adding hydrogen ions. And now I am going to balance my charges by adding electrons. For my top reaction, I've got positive 14, negative 2, so it's positive 12. I've got positive 6 over here, so I need 6 electrons to balance that out. And on this equation, I've got negative 2 and neutral, so I need 2 electrons to balance that out. And now I need to balance my electrons, so I'm going to multiply my bottom reaction by 3. And I add my 2 equations together. And we're going to cancel out anything that will cancel out. Our 6 electrons will cancel out, and it looks like that is it. So this is our answer. The last example we're going to look at takes place in a basic solution. With basic solutions, you have to add hydroxide ions instead of hydrogen ions to balance out the hydrogens. The problem is that the hydroxide has oxygen in it, which screws up your oxygen balance. So I'm going to show you something that maybe will make this a little bit easier, and hopefully won't confuse us too badly about what's going on. Now, you pretty much do this exactly the same way as we've done all the others. So start with your half reactions. Balance everything but your oxygens and hydrogens, which everything's already balanced. Balance your oxygens by adding water. Balance your hydrogens by adding hydrogen ions. And balance your electrons. Sorry, balance your charges by adding electrons. Okay, now here's the thing you have to do if it's a base. You're supposed to add hydroxides instead of hydrogen ions, but when you add the hydroxides, it screws up all your oxygen values and messes it up. So here's kind of the easy way to do this. The same number of hydrogen ions that you just added to these equations, you add the exact same number of hydroxide ions to both sides of the equation. So for my first reaction, I'm going to add 4 hydroxide ions to both sides of the equation. And for my bottom equation, I'm going to add 2 hydroxides to both sides of my equation. So what exactly does this do? Well, it pretty much neutralizes the hydrogen that you added earlier by adding to it to make water. It allows the hydroxide to be on the correct side of the equation without messing up your oxygen atoms. And it doesn't mean you have to learn a whole new set of rules. You just add in this one little extra rule at the end. So you can take these hydrogens and hydroxides that you added together, and you can just go ahead and make them water, right, and take them out. And then you can go ahead and cancel out, which is to say 4 2H2Os, and then you can go ahead and cancel out any H2Os that can cancel out, like on this top problem. These 2 H2Os cancel out, leaving me with just 2 H2Os on this side. And the H2O cancels out over here, leaving me with just 1 H2O on this side. So I'm going to rewrite my super messy equations here so we can see better what I just did. So here's my top equation and my bottom equation. Now to finish this up, I still need my 2 electrons to balance out, so I'm going to multiply my top equation by 2, my bottom equation by 3. And now I can take these 2 and I can add them together. So here we are all added together. Now I'm going to cancel out anything that will cancel out. My electrons will cancel out here. I'm also going to have some hydroxides that will cancel out. All of those will be gone, leaving me with 2 of these. And I'm going to have some waters that will cancel out. All of those will cancel out, leaving me with 1 of these. So if I rewrite this as my final balanced equation, then we get this as our final balanced redox equation.